We left off the last video with a solid description of the problems with the configuration we found when we walked into the project. 1. There was a physical connection between the ADC and the DMZ and the internal networks, and the management IP, NSIP, of the ADC was on the internal network. 2. As a result of this management connection to the internal network, we had a proliferation of static host routes in use to force data traffic through the firewall between the DMZ and internal networks. And 3, since the default route was pointing through the management interface, we were dependent on MAC-based forwarding to provide a path for return traffic to the public internet. Now, when we look at this drawing and all the hairpinning of traffic through the firewall, it looks excessively complicated, but this type of traffic flow is quite common in corporate networks, and there is nothing inherently wrong with it. It looks complicated, but it isn't. It strikes a good balance between the expense of buying an extra pair of firewalls for traffic between the DMZ and internal networks and the appearance of excess complexity. What we will do next is discuss the goals of the existing architecture and option number 1 for fixing the problems we just described. Option number 1 will remove the need for static host routes and the need for the use of MAC-based forwarding for return traffic to the public internet. Option number 1 isn't perfect, but since we're dealing with an existing implementation, perfect just might not be an option. The goal of this environment and the firewall placement is to create a DMZ network and force all traffic from the DMZ to the internal host through the firewall, and vice versa. So what's wrong with this picture? You get the dotted line showing the separation. What's wrong with the picture? You got it. There shouldn't be a physical connection between the ADC, which is on the DMZ, and the internal network. So how do we correct this? Option 1, we can simply remove the physical cable connection between the management interface on the ADC and the internal network. This requires us to change the management address of the ADC, also known as the NSIP, to an address in the VLAN 2 network. So something in 192.168.2.0/24. So this would turn the ADC architecture into a true one-arm configuration. All traffic into and out of the ADC would go through a single path, and all traffic into and out of the ADC would traverse the firewall. The only problem with this configuration would be that the management IP address of the ADC would be on the DMZ network. Generally, that's not advisable, but depending on the security policies in place, this may or may not be acceptable. So, since we're in a virtual environment, I'm going to avoid unplugging an interface, and we're just going to down interface 1.1. That will be the same as removing the management interface. It'll be a set interface 1.1 minus state disabled. Alright, so that effectively makes interface 1.1 usable, which means we only have one path. Same IP addresses still exist on the ADC. But what we do need to do is change the NetScaler IP to something in 192.168.2.0. Set nsconfig minus IP address 192.168.2.42. There you go. Whenever we do that, we have to reboot the ADC in order for it to take effect. So we'll save the config. This is taking a while, isn't it? Alright. Now we'll reboot the ADC. Which also takes a while, so we will fast forward through all of that and then come back when the ADC returns. Okay, so the ADC is back. We're going to log in again and fix the routing. Show run grep route. See, we don't have a default gateway. We'll just do add route 0.0.0.0, 0.0.0.0.0. Gateway 192.168.2.1. Let's save that config. One other thing I think we'll want to show here is that because we've changed that NSIP, we no longer have high availability connection with the secondary, and we'll need to repeat this process on the secondary ADC. So I'm not going to repeat the play-by-play as we go through the second ADC and shut down the interface and fix the IP and reboot. When we get back up after the reboot, I'll jump back in and talk some more. Okay, so the secondary ADC has come back up. We're going to log back in, fix the routing, and check the HA status. Verify that we can ping the other side. Add route 0.0.0.0.0.0.0. One thing you notice, you're on a console, so error messages pop up in the middle of what you're doing. Gateways 192.168.2.1. So that command line went in okay. If you look here, we can ping the other side. And I think we'll do show HA node, and you can see that we've lost connectivity to the other side. So now both ADCs are back up. We need to replace the HA configuration. So we'll go to System High Availability Nodes. This is on the primary, and we're going to choose that and set him for Stay Primary. And we'll go to the secondary and configure that one for Stay Secondary. This is so the secondary has no chance of overriding the config on the primary. While we're here, we'll change that sync VLAN to 2. Go back to the other side, verify that config. we need to change this sync VLAN to 2 as well. Okay. So now, on the primary, we can add the secondary and put them back in HA. Fill in the credentials. Take the secure access checkbox. Alright. We're just going to refresh until that in progress changes to success. There we go. Now we'll go back to the secondary. You can see that that config has been passed over. We're going to put this guy back into HA enabled state. You need to save that config. Those are saved locally even though it's an HA pair. So now we're back on the primary and we're going to set it for HA enabled. Hit refresh. Now they're up and active in high availability mode. Now let's go down and take a look at the static routes, because remember we had those static host routes. Those are no longer necessary with this configuration. Find it. There it is. Alright, so we're going to select all those static host routes. And delete. And of course it doesn't refresh. So we'll just click around for a second. We'll come back to this and verify that those were deleted. And there you go. Now if we go look at the load balancing configuration, we can see that the services are all up and running, except for one. It's the LDAP service did not come back up. Take a look at the monitor mining. Probe timed out. I think I know why this is, and that is because the health monitor for LDAP actually sources from the Netscaler IP. We just changed the Netscaler IP, so I need to go make a change in the firewall in order to get that corrected. So after that's done, we'll come back and take a look and verify that they all come back up. So I've made my firewall changes, and we come back and look. The LDAP service is now showing up. LDAP vServer is now showing up. I accidentally went in and turned off the MAC-based forwarding while the camera was off, but you guys already saw how to do that in the previous video, so I think that's okay. Everything's up and running. The only problem in my mind with this configuration is that the management IP address for the ADC is directly on the DMZ network. Your organization may find that acceptable, but I don't like it from a security perspective. So let's pop up a slide showing the new traffic flow with the changes we made. The new traffic flow hasn't changed from the old traffic flow. What we were able to do is remove the violation of the security goals by removing the connection between the ADC on the DMZ and the internal network that had the potential to allow traffic from the DMZ to internal networks to bypass the firewall. We were also able to remove a bunch of static host routes and turn off the MAC-based forwarding feature. I hope you've enjoyed the second video in this series and can see some light at the end of the tunnel for a painful pre-existing configuration. Option number 1 solves most of the problems, but I still don't like having the management interface on the DMZ network. In the next video in this series, we will show option number 2, which will correct this deficiency. The final video in this series will show one of the best ways to build an environment like this using an ADC and give the do's and don'ts of building a greenfield environment with Citrix ADC. If you find this interesting and would like to learn more, subscribe to our channel for more instructional videos. If you need help with your organization's technology challenges, please visit our website at positive-convexity.com and get in touch. Thanks for watching.